Hi, this is Mrs. Lloyd with Lesson 8-4, Natural Logarithms, Algebra 2, McGraw-Hill Review. Our lesson goals: simplify expressions with natural logarithms and solve exponential equations by using natural logarithms. To vocabulary: natural base exponential function, an exponential function with base e written as y equals e to the x. And e is not a variable, it is a constant, it has a value. In natural logarithm, the inverse of e to the x written as natural log of x. And this graph hopefully looks familiar to you because it looks very similar to when we did 2 to the x and the logarithm of that. So these are inverses again. Natural logs and e's are inverses. So let's start. Write each exponential equation in logarithmic form. And by logarithmic form this time, we're going to use the natural log. But let's first see if we can use what we've done previously. We could write log base e of 14 equals x. We have done that before. Then what we need to know is this log base e is the same thing as the natural log. Let's try that again. The log base e of x equals 7. And once again, that's the same thing as the natural log of x equals 7. Why don't you try that on these two? Now we're going to go opposite. So we're going to take these logarithms and write them in exponential form. We just figured out that the natural log is the same thing as log base e. So that can be my first step. And then I can write my exponential e to the x equals 9. Again, natural log is log base e. And then I can convert it. E to the 4 equals 3x. Try that one on this. Natural log of 4 is equal to 3x. Now let's use our properties of logarithms to simplify some natural log expressions. We want to simplify it down to a single logarithm. That means we will only have ln, or natural log, written one time. Let's think backwards on a few things. I can move this to become an exponent. I know that 8 to the 1/3, the cube root of 8 is 2, so I'm going to go natural log of 2 minus the natural log of 3 plus the natural log of 9. Now I'm going to work, I have add and subtract. Order of operations says I need to go left to right, so I have a subtraction here, so I can condense this to the natural log of 2 divided by 3 plus the natural log of 9. And finally, I only have add, so I can change that to the natural log of 2/3, add becomes multiply, times 9. And 2/3 times 9 is, 2 times 9 is 18 divided by 3 is 6, the natural log of 6. And it wants us to leave it that way, but I will show you that has a value. Go to functions and look for natural logs right here. So the natural log is 6. We could get the decimal. That's not what we're supposed to do. I'm just showing you can also do that on a calculator. Let's try that again. Break down what we know. First thing I see is I can make this an exponent. So the natural log of 7 minus the natural log of 27 to the 1/3 plus the natural log of 6. I know that 27 to the 1/3 is the same thing as cube root of 27, which is 3. Now again, I'm going to work left to right. So I have the natural log. I have division, so that becomes, I have subtraction, so that becomes division. And now again, I only have addition, so that can become multiplication. And then 7/3 times 6 is 14. 42 divided by 3, 14. Natural log of 14. So natural logs use the same properties as base 10 logs or any base logarithms. And we now need to solve some equations. We did that with logarithms. Now we have this e, so we're going to need to use some natural logs instead of logarithms. But basically, it's the same sort of thing. First thing I'm going to do, I'm trying to get this part by itself. But to do that, I've got to work my way through the order of operations backwards, just like when you solve any equation. So the first thing I'm going to do is subtract 8. Negative 2 times e to the x plus 3 equals negative 22. Then I'm going to divide by negative 2. E to the x plus 3 equals 11. And now my exponent is, my variable is in the exponent. Remember, I can bring this around. X plus 3. There we go again. And since it's in e, I need to take the natural log of that. I'm going to divide both sides by the natural log of e. And let's go do that on a calculator. So I need to do the natural log of 11. I'll just go ahead and adapt this one. Divided by the natural log of e. Now, I don't know where that's at on this calculator. Nope. Maybe you can just type an E. There you go. You can. So we need 2.397, 9 times out of 8 to become a 9, 2.3979. And now subtract 3 from both sides. X equals negative 0.6021. And let's try it again. So I am trying to get this portion by itself. So for my first step, I'm going to divide both sides by 6. (26) divided by 6, 4.3333. Says go 10,000, so that's where I'm going to go on each one of my calculations. Now my variable is in my exponent, so I'm going to bring it to the front. And take the natural log of e and the natural log of 4.333. We're going to divide both sides, so I'm trying to get this portion by itself still. Natural log 4.3333, divided by the natural log of e. Now that I know how to do that, I can just adapt this one. Natural log of 4.3333 divided by the natural log of e, 10.6767. Nope. Missed a decimal. I knew that wasn't right. 433. There we go. 1.4663. 1.4663. Now just solve this two-step equation that's left. Subtract 3. 0.25x equals negative 1.5337 divided by 0.25. X equals negative 6.1347. I think I have one or two more. This one doesn't have an E. This one has a natural log. So in my first step, I need to get this portion by itself. So I either need to divide by 1/6 or I could multiply by the reciprocal. So I'm going to multiply both sides by 6. Natural log of 5x is equal to 12. Now I can kind of use the opposite or the inverse of what we've been doing. I can write this as e raised to the natural log of 5x is equal to e raised to the 12th we need to go over here and think about something. E just something you need to know. So when I raise e to the natural log of x, e raised to the natural log kind of cancels each other, and so all you have is x. So e raised to the natural log of x is just equal to x. So here I have e raised to the natural log of 5x. These cancel, and I have 5x, is equal to e to the 12th. 5x is equal to e raised to the 12th power. E is 2 point something. This is going to be a decently big number. Let's go over here and do e raised to the 12th. 162,754.791. We need to go 4 places. 7914. Okay. 162,754. 162,754 point, let's go back, 7914. And finally, we can divide by 5. X equals 32,550.9583. This is your key. Remember this. I think we need to try it one more time. Natural log of x plus 3 equals 5. E raised to the natural log of x plus 3 equals e raised to the 5th. When I'm using this pencil sort of thing, I can't touch the screen and write. These cancel. X plus 3 equals e raised to the 5th. We need to get e raised to the 5th. I'm going to get it on my other calculator over here to the side because it has an e button. 148.4132. And now just subtract 3. 145.4132. That was a lot for one day, but I wanted you to be exposed to all this. I don't know how much you will see it except in a college class, but at least you've seen it once before if you ever see it again. Thanks for watching.